I looked around on the internet for a Wankel Rotary engine, and I was disappointed to find one that was actually modeled correctly. I looked in various locations like GrabCAD, and I couldn't find one that was actually modeled. So I want to demonstrate how to create a rotary engine from geometry. So we don't really have to know everything about the design, just some key parameters, and then the geometry will fall in place. So the first thing I'll do is I'm going to create the gear set for the engine, and then we'll work backwards creating the rotor. So I'm going to create a ring gear, and so I've got this set to internal. I've set this to a module of 1.75, and I'm going to do 34 teeth for the pinion gear and 51 teeth for the ring gear. That'll give us a ratio of 1 to 1.5. For the face width, I'll do 20. I'm going to put a slight helix angle on of 5 degrees. And so let me just go ahead and put this in to my assembly. Okay, and I'll click here to place it on that face. Now we'll end up moving that later on to get it. So I'm going to open up the spur gear, and I'm going to make this a different color just to make it show out well. So I'm going to do this as chrome. Now in the assembly, this gear is fixed in place. So there are some mounting holes on the front of this gear, and then it's bolted to a faceplate that goes on the front of the engine, so this gear doesn't move. The ring gear that we'll edit here in a minute walks its way around this pinion gear. So let's start a new sketch on this face, and I'm going to draw a circle at the origin, and I'm going to make this circle, say, a diameter of 40. And I'll do an extrude cut through all of that circle. Okay, and then I want to put some mounting holes in here, and so I will start a new sketch on this face, and I'm going to draw a circle. Let's put the mounting holes about right there, so let's make that diameter 47.5. And then I'll put a point at the 12 o'clock position, and I might put a vertical relation in between that point and the origin. Okay, I'll go ahead and put my hole at that location, so I'll tell it to do a threaded hole. And let's set that to metric profile. I'll do an M5, and let's set the tap depth to 10 millimeters, and I'll set the drill depth to 15 millimeters, and I'll set the tap depth to 10 millimeters. Okay, I want to add a chamfer to that as well, so let's go ahead and go back and edit that feature, and let's okay, I'll do a circular pattern of that feature, and I'll tell it 6 copies, and I'll say OK to that. Let's put a chamfer on this edge and this edge as well, so I'll select that edge and I'll do a chamfer. Let's do that, say 1 millimeter, and I'll get both of those edges. Alright, I want to turn on the visibility of the pitch diameter circle, because we're going to need that when we get into the dynamic simulation environment. I've done a few things correct, so I'm going to go ahead and save this. And then I'm also going to use one of the parameters when we go to design the camshaft for this. And so I'm going to go to the Manage tab, and I'll go to Parameters, and I'm looking for the parameter DADW, that's the pitch diameter. And so I'm going to mark that for export. Okay, so I've marked that for export, and let's go ahead and put a note here that that's the pitch diameter. Okay, I've completed that component, and now I'll work on the ring gear. And so let me open up that ring gear. Let's go ahead and turn on that pitch diameter so that we can see that surface for the pitch diameter. And while we're thinking about that, let's go ahead and mark that DW, and that's AW. I need to find DW, DADW, and I'll mark that for the export. And so let's name that, put a note in here. This is the pitch diameter. Now you might wonder, how did I know that? Well, if I edit that sketch and I double click on that dimension, I see that it's DA_DW. So that's my pitch diameter. Okay, I'm going to start a new sketch, and I'm going to do this on the XY plane. I'll draw a circle, and when I draw this circle, there isn't any specific size. I'm just making something appropriate for the size of the block that I have. And so let's go ahead and I'll do this one at 210 diameter. And I'm going to draw a triangle then at the origin. I'll put a horizontal constraint on one of these lines. It turns dark. I'll change all of that to construction geometry. And then I'm going to draw an arc from here over to here, and I'll make this a radius of, say, 215. And I'll do two more arcs in here, so I'll do another arc from here to here, and I'll do an arc from here to here. And I'll make those arcs all equal to each other. So I'll select those three arcs, and I'll do equal. They all turn dark. Now let's finish sketch and save this. And we'll go back to the assembly, and again, the numbers that I used, I don't have this thing centered up yet, but the numbers that I used were just to make something that's appropriate for this block, for the size of the block. And so there aren't any, we could adjust those numbers to whatever we need to make it fit inside this block. Okay, I will, and then of course we can always go back and edit the dimensions later on if we decided that's not quite the size that we want. I'm going to go ahead and extrude this now, and actually before I extrude it, I think I'll do a couple more sketches for some geometry that we're going to use, or at least one more sketch. Let me see. I want to put a hole in this. We're going to actually make this as a multi-body solid, so I need a hole for this ring gear, and then I need a hole for the crankshaft. So I'll do a new sketch on the XY plane, and let's project geometry, and I'm going to assume that this is a press fit into this housing, so I'll just project that geometry, and then I'll do another sketch on the XY plane, and I'll draw a circle for my crankshaft, and let's make that a diameter of 70. Alright, now I'm going to I'll roll up my end of part marker so that I just have this first sketch so we can see what we're going to do. And actually I decided I want one more sketch in here, so let's do another sketch on the front plane. And I'm going to project geometry this point right here, and I'll draw a rectangle, and at first I'll put that rectangle out in space, and let's dimension the width of that rectangle as 4 millimeters and the height of it as 15 millimeters. And then I'm going to put the midpoint of this line at this point that we projected from the previous sketch. Right now I'll roll up my feature tree, and I'm going to extrude this, and I want to make a new part, so I'll tell it to do a new component. I'm going to go 20 millimeters in this direction, so let's tell it to go in asymmetrically, so I'll go 20 millimeters in that direction, and I'll go 30 millimeters in the back direction for a total of 50 millimeters. Okay, so I've created a new component here. Alright, I'm going to temporarily turn off the visibility of the ring gear, and I will I'll drag my end of part marker down so I see that next sketch, and I'm going to extrude that, and I'll tell that to go through all, and I want it to come out in this direction. I want it to do cut, and so that cuts a cavity for our ring gear, and then I will do the hole for the crankshaft. I'll tell that to go through all, and now I will I'll do a cut for a piece that goes in here, and there's actually 3 of those wipers that we'll see how that works in a little bit. So I'm going to do extrude, and I'm going to do cut through all, both directions, mid-plane. Alright, let's pattern this around the part, so I'll do a circular pattern, and for the feature I want to pattern is this last extruded cut. I want to pattern it 3 copies, and then I'll put some fillets here on the edges of that. So let's do a fillet, and I'm going to do 0.05. Just break that sharp edge. Let's do that 0.5, half a millimeter. Okay, I'm going to turn the visibility of the ring gear back on. Okay, so here we have our ring gear. Let's change the properties of that to chrome, just so we can see that stand out better. Okay, so there's our ring gear. We have the pitch diameter, and we've exported that parameter for the pitch diameter. I want to do one more step here before I leave, and let's turn on the visibility of the sketch that we used to make this, and I want to keep track of this point right here. So let's put a work point at that location as well. Okay, now I'll turn off the visibility of that sketch. Okay, so I have that point where this arc would come down and this arc would come down, that theoretical intersection out there in space. So let's go ahead and save this one, and then we'll model the crankshaft. Let's add a couple of additional features to these parts, and then we'll continue with generating the crankshaft. I'm going to put my part selection priority on part priority, and I will tell it to open this part, and I'm going to put a chamfer on these edges, and let's make that 1 millimeter on this edge and this edge, so that the crankshaft will go into that hole easily. And then let's turn off the visibility of this part. I also am going to put a chamfer on this edge so that we can put the, actually let's just edit that previous chamfer, and we'll add this edge. Okay, so I put those chamfers in, and now on the first part, in order to make it easy to slide in, and it's actually press fit, and so we can line that up when we're press fitting that in. Let's put a chamfer on this edge as well. We might chamfer this edge just to break the sharp edge, so let's edit that chamfer, and we'll add it to the outside edge as well. Okay, I'll turn on the visibility of both my solids. And we're going to treat this as one part with two solid bodies within that part. If we want to, we can push out the individual components. Alright, so I want to make the crankshaft, and to do that I'm going to start a new part file. I'll start a standard millimeter part, and then I'm going to do a derived component to get those parameters that we exported or set to export later or earlier. So I'm going to do derive, and I will go into the individual part files, and I'll say OK to that. And then what I want is a couple of the parameters. I don't need the solid bodies, I just need those parameters, and actually, so I've marked that parameter for export, so it's already selected, so I'll say OK to that. So I brought that parameter in, and I'm going to do the same thing for the other part. So I'll do derive again, and I'll go and get the second gear, and I don't need the work geometry, I don't need the surface bodies of the solid body, I just need that parameter, that model parameter that we marked. And I'll select this DA underscore DW here. I'm not sure why it was showing the that one. I'll just go ahead and turn that one off. Now it might be, well, let's just go ahead and say OK to it and see. Alright, so I'll go to my parameters now, and I see, and so it put a underscore 1 on it because they both had the same name, and this was the second one that we brought in. So we've got the two parameters that we want. Alright, I'm going to start a new sketch on the front plane, and so I'll go to the XY plane, and I'll tell it to do a new sketch, and I'm going to draw a circle at the origin, and then I'm going to draw a line coming down from the origin, and then I will draw a second circle from the end of this line up to the tangent point up here. Now if I had trouble getting it, just add the tangent after the fact. Alright, so I'll go ahead and dimension these circles, and I'm going to tell it to list parameters, and I'm going to make that equal to that first imported pitch diameter, and then I will dimension the second circle, and I'll list parameters, and I'll make that equal to the second pitch diameter. Okay, so those are the two pitch diameters that we used when creating the gears. I'm going to change all of this to construction geometry. Right, and then I need to make the shaft for the let's do the outer circle first, and so I'm going to make this, and well, let's do both circles. So I'll do this circle, and remember we made our hole as 40 millimeters. So I want to allow a little bit of clearance in the hole for the shaft. So I'm going to do 39.9, so it's a little less than 40. And then I will make this arc tangent to that arc, and this will be for the hole in the rotor, and then this is for the hole in the block. Alright, we'll see all this come together here in a few minutes. I will do extrude, and I'm going to extrude both of these, and let's do that a distance of 30 millimeters. I'll put a fillet on these edges. Let's do that fillet 0.5 on both of these edges. I'll make that sketch visible again. And I'll do extrude, and this time I'll pick only the inside, and I'm going to join this. And I'm going to go a distance of 50 in one direction, and then in the second direction we'll go 50 as well. So we can just make that midplane 100. Right, let me turn off the visibility of before I do that now. So again, we use the pitch diameters of the two gears to help us generate. That gave us the distance, the center to center distance between the offset of the cam lobe and the crankshaft axis, without doing any calculations. So all of our geometry is based on the original geometry. If I make any changes, it will all update associatively. So we'll turn off the visibility of that sketch, and I'll do a chamfer on the ends here. Let's make that 1 millimeter, and I'll get that edge as well. Okay, let's make this part. I'll make that steel, some kind of steel, and I'm going to make it chrome plate. Let's name that crankshaft. I've promoted the two subassembly gears up to the main assembly to make this a little bit easier to work with. And so first thing I'm going to do is I will constrain the axis of the crankshaft to the axis of the assembly, and then I want the this face to be flush with this face, and so I'll constrain flush this face and this face. Okay, so now the crankshaft has 1 degree of freedom left, a rotational degree of freedom. Let's make this part a clear color so that we can see what's going on inside of the block before we cut it out. And so I'm going to make that a clear green. Alright, so if I rotate the crank, we see that the crankshaft rotates around the z-axis. And then I'm going to constrain this part to the assembly. So I'll constrain the axis of this part to the z-axis. And again, I want to move that out here to the front, and so I'll constrain flush this face against this face. Okay, now this has 1 degree of freedom. We're going to remove that remaining degree of freedom here in a few minutes, because remember, this piece is bolted through these screw holes to the front housing plate that would go over the front of this block, but we haven't modeled that part. Alright, and then I will constrain, and this time I'm going to constrain the axis of the ring gear to the axis of the cam lobe on the crank. And it might be a little bit easier to select if I first turn off the visibility of the housing. Right now I'll do my constraint, this axis to that axis. So I'll do flush between here and here. Okay. Now I want to put a 0 position for this so that we can line everything up. And so I'm going to put a temporary constraint between the YZ plane of the ring gear, and let's do flush, and the YZ plane of the assembly. Now, so that I don't forget, let's go into here, into the relationships, and let's go ahead and rename this as suppress this. So I might name it as suppress this, or 0 position, or something to give me, to remind me in the future that I actually want that suppressed. Now I won't suppress it just yet. I don't want to line up these teeth on the pinion, and now I'm going to lock that pinion in place. Because remember, that's bolted to the front of the engine. So I'm going to ground that. Okay, so now it's grounded. And then I'm going to put my rotational joint or constraint between these two parts. And so I'll do constraint, I'll do rotation, and I'm going to put it forward direction, select the larger pitch diameter first, and then select the smaller pitch diameter. You see that ratio 1.5, and I will say OK to that. And then I'm going to suppress the constraint that I said suppress this. So I'll suppress that, and I'll test this out, and we see that the rotor now walks its way around the pinion gear. Alright, I'm going to resuppress that temporarily just to get it back into position. Okay, so I've got this back to the 0 position. Then I'll suppress it, and I'll go into dynamic simulation. And let's turn on the housing before we go into dynamic simulation. Okay, so I'll go to my environments, dynamic simulation, and I have a revolution joint between the crankshaft and the housing, and a revolution joint between the spur gear, the pinion gear, and the crankshaft. I will actually, this is between the crankshaft and the ring gear. Alright, I'm going to tell it to revolve, and I will then go to the properties of the revolution 1. We have 1 degree of freedom revolution. Now I have 3 lobes on here. In order to do the 1 complete revolution of the rotor, I need to do 3 revolutions of the crankshaft. So I'll set it to go for 3 seconds because it does 1 revolution in 1 second. So I'll go ahead and play that, and when we do, now I put a trace um, on this point right here, and but I see that it's just going around in a circle. It's not operating correctly. So I'm going to rewind that, go back to construction, and I forgot to show you this point where I put a trace on there. So I selected a trace, and then I selected that point down inside there. It's easier to select if you turn off the body, or if you just right click and tell it to do select other, you can get that work point. So I've already got that trace placed on here. Alright, so I need to get this set up with a rolling cylinder on cylinder, or in cylinder joint. And so it'll be easier if I turn off the visibility of the grounded component, the housing. Okay. And then I will insert a joint, and I'll do the rolling cylinder in cylinder. It asks me to select the outer component first, then the inner component. I already have the parts in position, so I don't need tangency. If I add the tangency, it's going to give me an error. So I will I'll select the outer circle first, and then I'll select the inner component, and I'll say OK to those. Alright, let me turn on the visibility of the grounded component, the housing. And let's turn on shaded with edges to make this a little bit easier to see. Okay, and so then we're going to follow this point as it goes around. And I think I'm going in the wrong direction. It really doesn't matter which direction I'm going, but we'll go ahead and play it. Okay, so it's just tracing out that location on the rotor, that point location. Let me see. Okay, so we've completed that rotation, and I'm going to expand the output grapher. I've set an imposed motion of 600 RPMs on our crankshaft, and Inventor then converts that into 3600 degrees per second. And so I need to do three revolutions of the crankshaft in order to get 1 revolution of the rotor, and so I'll need to run it at 0.3 seconds in order to get that 3 revolutions of the crankshaft. So I'll go ahead and put it in motion, and it calculates the position of this point and draws a trace as it goes around. Okay, so we have that complex path that is generated by the geometry. We don't have to do a calculation to try to figure out what that path is. I'll go to my output grapher, and I will right click on that trace and tell it to export that to a sketch. And it isn't real obvious, but down here it tells me to select the component that I want that sketch to be in. So I'll select the block. Once I have my trace exported to sketch, I can close down the output grapher, I'll rewind back to the beginning, and I'll finish dynamic simulation, save everything that I have, and then I'll open up the block, and I'm going to then do an extrude of that sketch, and I'm going to tell it to go mid-plane through all. I want to cut out that opening. Okay. And then I've also set this to cut out the openings for the intake port and the openings for the spark plugs. Okay, so those are the openings. I will save this and then go back to my assembly, and let's set this back to a solid view. And so I'm going to make that aluminum. And we'll go back to dynamic simulation and we'll run it again. So I'll go to dynamic simulation, and I'm going to turn off the visibility of the trace, or delete it. We could leave it on for now, and we turn on the shaded with edges, and we now play this. And so we've used this geometry to generate the opening in our engine block for the rotor to follow.